Welcome to Tetrionics. In this lecture we'll be covering the quantum geometry that gives rise to all the physical constants in our universe. This lecture contains material extracted from Tetrionics book 1 and 2 with a small section from Tetrionic book 4. Obviously quantum mechanics, electrodynamics and gravitation are all formulated in mathematics using physical constants. All this material is available on YouTube and Google Plus or upon request via email. Tetrionics has three foundational laws to its geometry. The first one being obviously that square numbers in physics are in fact equilateral geometries or are derived from equilateral geometries. In the case of Planck's constant, the quantum of energy, mass and momentum, the square number is directly related to the equilateral geometry that gives rise to the angular momentum in Planck's constant. The second law is that all energy, or energy in all its forms, seeks a state of equilibrium. It does this through charged interactions or through changes in energy density, or simply the equalization of charge or mass matter densities. This is the force or the law that gives rise to all our physical forces, the second law of equilibrium. There is a third law which simply states that there are no infinities in Tetrionics, and this is because Tetrionics is a finite geometry for energy in all its forms, be it mass, energy or matter. And in physics, the physics itself is the motion or the measurement of the motion of charged particles of matter through any region or volume of space. Planck's constant itself is the fundamental quantum of mass, energy, momenta. It contains both linear momenta, or momentum, and quantized angular momentum, designated by alpha. Again, alpha is simply square meters per second. It's a measurement of the area. This is traditionally viewed within electromechanics particularly as a flux in one direction or the other, or a vector rotation about a point in physics itself. Using the electrical vector rotation for quantized angular momentum, we can develop a electrical model of zero-point fields or zero-point energy, Planck's constant, and its geometry. The flux in one direction or the other within this closed or short-circuited quantum inductor will produce either a south-north or a north-south magnetic dipole in the inductor. This short-circuited inductor, in addition to having a distinct magnetic dipole, will also resist changes in the energy level, whether it's adding energy or subtracting energy from the circuit. This is exactly what happens with the equilateral geometries within Tetrionics. Any changes that must be affected within the circuit are done so by odd-numbered bosons or transverse masses. But the equilateral geometry itself is what is the quantum of inertial mass, as defined in Newton's laws, F equals ma. Any change of energy will bring about a change in the linear momentum, or the square root of the scalar field, as well as affecting the number of quanta within that field, and obviously their wavelengths. And these are all obviously related by the velocity. Frequency by wavelength gives us velocity of propagation. What is invariant obviously is the geometry of this field, or its alpha, the quantized angular momentum, and it's alpha per c squared that gives us charge. So these are the two forms of charge that are present in any Planck quanta. And again, the Planck quanta itself is a form of electromagnetic energy, so it will have an electric field, a magnetic dipole, and it can be measured per unit of time to give us a unit of mass, or a measurement of mass. Again, Planck's constant's most familiarly known to most as h, and its units are mass by angular momentum. In Tetrionics, we simply refer to it as mass alpha. Either side of any two-dimensional zero-point field or zero-point energy has two distinct charges. One side has a negative charge, and the opposite side of the field itself will have a positive charge, or vice versa. This results in the charge being neutralized, or more or less undetectable, save for when it forms matter geometries. When it forms the matter geometries, obviously one side of these quantum fields is within the matter geometry and can no longer be detected, leaving the externalized geometries outside for detection. And this is how we form our larger scale elementary charges and matter itself. Obviously, in the case of the magnetic dipole on a quantum coin or a Planck coin of energy, we have a situation where even though the electric charge itself is neutralized, the magnetic moment is not. It's in fact always a south-north looking at it from this side and a north-south looking at the other, because it will obviously be a positive, in which case we have a strengthened or emphasized magnetic dipole within Planck's constants. And this dipole can obviously be used to indicate direction of motion, etc., where we have charged particles in motion and energy in chem fields. But again, just to point out, whilst the electric charge itself is neutralized and the electric fields, the magnetic dipole is not. It's this geometry of quantized angular momentum that gives rise to many of our, or all should be an appropriate term, gives rise to all of our physical constants. In the case of gravitation, it gives rise indirectly, but everything in the universe, ourselves included, and the forces between every material object, is the result of equilateral mass energy geometries, or Planck's constant. Of course, there's many geometries you can use to express square areas and other measurements of units in order to determine constants such as pi or golden ratios, phi, or even things like Coulomb's force, gravitational force, etc. But in all cases, Tetrionics shows that whatever mathematics is used to describe the physics of these forces and objects, they all relate back to a fundamental geometry. The mathematics of physics is simply our attempt to provide a language to what the underlying geometry is. The geometry gives rise to the fields, gives rise to mass, energy, matter, momentum in its various forms, and it's the interaction of these geometries that gives us our fields of force within physics. The mathematics is simply us describing these interactions. The first and most fundamental measurement we can make is that of empty space. There are lectures available on coordinate systems themselves, but at this point we'll simply say that in the x, y and z directions, in the case of Cartesian coordinate systems illustrated here, we simply take the three axes and we assign a unit of measurement. And this can be anything, although in physics, after the development of relativity, where it was stated that the speed of energy in a vacuum, or the speed of light, was a constant, a lot of these coordinate systems became based on c. So accordingly, if you see c to the x, you know it's referring as a spatial coordinate system. You know it's referring to the directions or the dimensions of the region of space being measured. And empty space itself, as defined in this matter, is completely empty. There is no energy in any form, mass or matter, or energy itself, on which we can take a measurement. There are no forces generated by the absence of mass, energy, matter, so therefore it is truly empty space. In reality, the universe doesn't contain empty space as such. The only place that a region like this would exist, completely devoid of energy in all its form, is within matter, geometries themselves. But as a definition of a coordinate system, we simply define it as empty space, and then we're measuring energy in all its form and motions within that region bounded by our coordinate system. As I just mentioned, we have a number of coordinate systems we can develop using the speed of natural speed of energy as a form of measurement for the linear vectors for each axis. In the case of C, we can measure a straight linear force. It's just the distance per unit of time measured by energy as it radiates out. This is normally associated with charge or energy fields. Where you have photons, where you have two charges back to back to give it a single photon frequency, you produce c squared because you have a bidirectional radiation of energy as opposed to charge. So in this case you'll have c by c, or c squared. Of course there's the Cartesian coordinates we've just mentioned and illustrated on the previous page, and they give us a coordinate system of c cubed, or cubic volumes. The most common one you'll come across, particularly as you get into general relativity, etc., is c to the fourth. C to the fourth is created in two separate ways. Both cases it relates to propagation of light. Obviously, c squared by c squared gives you c to the fourth, so it's a spherical measurement with light propagating linearly and horizontally within the same region from a point. As they do that, they'll obviously map out two circles, creating a spherical coordinate system for measurements to take place in. It has the advantage over c cubed in that it's more accommodating for spherical geometries, and it also has a negative z-axis as well. The other way to create a c to the fourth measurement is where we have superpositioned energy fields. So c squared by c squared, where the two fields overlap and interact with each other via their energy momentum, as we discussed in the previous lecture. This is the other reason for using c to the fourth spherical coordinates rather than Cartesian, because then where we have bodies of mass matter interacting via their in spherical coordinate systems, the fields of force created by their black body and chem field interactions will rationalize out. They again, where they superposition, will become c to the fourth, rationalizing the units of measurement, as opposed to a c to the fourth within c to the third if we used Cartesian coordinates for physics and the interactions. And this is illustrated on this page. Vector measurements are just done in velocity or speed of energy. Measurements of two-dimensional mass energies are formally done in Tetrionics as in units of c squared. Obviously where you see c squared now, you'll know that it refers to two-dimensional mass energies, planar Euclidean geometries. You'll rarely see cubic volumes, except where we're correcting existing formulations for things like black hole entropy and information loss, etc., where, as a legacy of their earlier development of the theories with Boltzmann, etc., they've remained in their c cubed geometries and then been applied to spherical coordinate systems, in which case they have to be recorrected because they're describing information in a cubic coordinate system or a Cartesian coordinate system within a spherical geometry for mass matter energy, and this needs to be rectified. And obviously we have the spherical volumes I just discussed, where we have a z component, negative component to the z, as well as our x, and we can obviously have y coordinates as well within the same volume of space. But importantly, despite the radial geometries of c squared and c to the fourth, all mass energy matter is equilateral or comprised of equilateral geometries. And it's these equilateral mass energy matter geometries and their motions within any region of a spatial coordinate system that gives us our measurements or our physics. Energy itself is simply a equilateral geometry within a radial measurement of time or a radial coordinate system. Energy is by itself will radiate out or propagate from a point or its source point. In the case of charges, it's an equilateral geometry, and it radiates in the direction of the E field. This may be transverse or it may be longitudinally with respect to the direction of propagation as well, creating two distinct forms of electromagnetic waves. Obviously, if this was a photon comprised of two charged quanta, the geometry would change from a equilateral triangle to a diamond shape, reflective of the charged geometry of photons. And this applies to all forms, be it bosons or photons, or charged fields, which are bosons. Irrespective of their charged geometry, if they're two-dimensional or Euclidean mass energies in a charged geometry, they're considered to be, well, they're termed as radiant mass energy in Tetrionics. And as they radiate out from their point per unit of time, they follow the inverse square law. As the distance increases, the strength of the field decreases in proportion to the square of the distance, or the square of the unit time in this case, which is a radial measurement. Obviously, in the case of three-dimensional matter, matter itself is a standing wave geometry, takes up three dimensions of space, so therefore we have to change the coordinate system to measure matter itself. And matter itself, although it has its energy momenta or mass energy momenta, propagates at the natural speed of energy in that geometry, it does so as a standing wave. So per unit of time, if this was a drawing of matter or a tetryon quantum of matter, the radial measurements of time would increase, but the matter geometry would not, as it's a standing wave and its propagation is completely internal within the standing wave. Planck's constant is probably the most important constant after alpha itself, and in fact it's formed from alpha. Alpha again is just the quantized angular momentum. It's the number of equilateral quanta available, square meters for the geometry per second per unit of time. Of course, energy within this field measured per second will give us a measurement of mass. And in Tetrionics, mass by quantized angular momentum, or mass alpha, as we'll refer to it from here on in, is in fact Planck's H, or Planck's constant. Again, the mass energy will fluctuate. It will be related to itself through the square of the speed of light, E equals mc squared, as Einstein defined it for inertial mass energy. But the constant part of the equation is the quantized angular momentum, or the alpha. And it's the alpha that's been hidden from physics in the mathematical study of physics, because Planck's constant has never been realized in terms of geometry. Again, alpha is the equilateral geometry of quantized angular momentum. It's this geometry that gives us a major chunk of all our constants. And it's the geometry that determines the strength of interaction and how these fields interact to create our physical constants. Again, we can obviously, even though it has a physical equilateral geometry, which people new to this subject will be getting their heads around, but again, it is odd-numbered equilateral geometries that give us our W bosons, and the addition of these W bosons in sequence gives us our scalar square energy or square number energy fields in physics. And these obviously can be represented with an electrical equivalent of EM energy flux in a clockwise or anti-clockwise direction. But in fact, this rotation is not what's happening. At the quantum level in quantum mechanics, there is no vector rotation about a point for quantized angular momentum. It is simply an equilateral geometry. As I mentioned, pi and c to the fourth appear in a lot of places within physics due to the mathematical formulation. Historically, though, they've never explained, or it's never been explained, what c to the fourth, c squared, etc. mean, other than their natural units that come out of the way the mathematics evolves. And likewise, it's been assumed that where 4 pi exists, for example, that it's referring to a spherical surface or a spherical geometry, when in fact Tetrionics shows us that these c to the fourth in a number of cases actually refers to tetrahedral geometries, particularly where they refer to standing wave mass energies, or to fields of force where the 4 pi is in fact the superpositioning of two pi electric fields, or fields of electric permittivity. Again, it is the geometry of the energy momenta within these fields that gives us the force between the charges, and it varies inversely to the square of the distance. So it's a diamond shape. Coincidentally, so are photons, which is the carrier, the longitudinal carrier of force. Bosons don't carry force, they carry charge. So transverse bosons, odd-numbered geometries, are charge carriers, and longitudinal even-numbered quanta are the electromagnetic force carriers, because that's the direction that the linear momentum acts in within the equilateral geometries of all fields of mass energy. So Tetrionics itself uses the standard formulations in most cases for physics as they've been derived and measured and tested. What it does is it changes the underlying geometry that has been assumed to be the case based on this physics. In fact, we'll show that in most cases, well, in all cases, it's derived from equilateral geometries, and in most cases you don't have spherical measurements of these fields. As I said, 4 pi is often taken to be a spherical measurement of the forces between two charges. It is in fact two diamond-shaped E fields superpositioned. Again, the E field mass energy is measured by taking the diamond-shaped energy fields, the 2 pi energy fields, tau pi, and using a spherical coordinate system, this time c squared, to equate it back to mass. So we have a mass energy equivalence, E equals mc squared, but where we have two of these fields superpositioning by their mass energy momenta, obviously we have c squared on c squared, and this harks back to the mass energy velocity or momenta relationship discussed in the previous lecture, where it's traditionally described as being having a right-angled triangle geometry for mass energy momenta, particularly in relativistic terms. Again, we rearrange that underlying geometry from right-angled triangles to equilateral triangles of energy momenta. These equilateral triangles or charged bosons can obviously increase their energy momenta within their fields, and as they do so, they strengthen their magnetic dipoles. This then forms the first of the nuclear forces, the weak force. And again, its strength of interaction is determined by the number of energy momenta, or the Compton frequency of the Planck quanta within its charge geometry. Again, the alpha per c squared, the charge geometry, is invariant. It does not change. It is a physical constant. It's the hidden constant alpha, acting out through a measurement of spherical coordinate systems. And the energy momenta within that field, although it varies, will give rise to electric and magnetic fields whose strengths can be determined by the energy momenta within them. Again, the strength and the constant itself for the electric field permittivity and the constant for the magnetic permeability are determined by their geometries. Electric fields having diamond shapes, magnetic poles, equilateral, forming a dual or a tau magnetic pole dipole, north-south, south-north arrangements. It's the weak force that first brings these charged mass-energy fascia together and allows us to create the energy fields of bosons, photons, etc. They also facilitate the construction of larger scale matter, as discussed in previous lectures and as illustrated on the right hand side here. And these geometries are 4n pi tetrahedral geometries, not spherical. So the first geometry will be a 4 pi geometry, which we term the quantum of matter, or a tetryon. And this is where Tetrionics gets its name. In doing so, we create charged and uncharged geometries from the arrangement of the charged fascia themselves. Again, it's only the external fascia of the fields in the standing wave that contribute to the net charge that we can measure on any particle. And again, this changes as tetryons come together via the secondary force. The secondary force obviously being the strong force, where tetryons of charged and uncharged quanta come together. They always interact with two charges with a dipole or a neutral tetryon, and these are referred to in the standard model as gluons. The neutral particles act as a dielectric between the charges, keeping them separated. And you can also have another arrangement where we have a charged particle surrounded, obviously, by two dielectrics or two gluons. These are an unstable state and they form what's called quarks. You can get 3 or more charged particles coming together and they form the leptons. Although quarks and leptons have the same 12 pi charged geometries, they differ in their actual physical geometry because of the interaction of the strong force. In the case of quarks, the opposite charged fascia come together, and the strong force being the parallel fascia interacting via their similar charges, opposite charges I should say, in the case of quarks. So the opposites attract and they form these partial elementary charged particles of matter. Of course, in Tetrionics there are no partial charges. They are all integers, 4 or 8 in the case of quarks, where they come together and the strong force pushes in complete charge sets, positive or negative, and form and interact, I should say, via their charge fascias, which are again similar charges. They create a different geometry, and that's the geometry of the leptons. Again, we have positive, negative and neutral charged leptons being created, charged ones being obviously electrons and positrons, the neutrals being neutrinos. But again, the physical relationship between mass and energy that is released within the matter geometries as we collapse them in fission or fusion is related through the geometry E equals mc squared. In this case we're referring to, in the case of collapse of the matter, we're referring to the velocity of the energy as it propagates within the standing wave geometry. In the case of pure equivalence, again still E equals mc squared, but it's referring to the equivalence between the energy content without a time measurement to that of a mass measurement of the same field when you take it per unit of time. Tetrionics refers to all these charged fascia, irrespective of their mass energy content, as a pi geometry, or a radian geometry of pi. We do this because once we have four charged fascia coming together to form the quantum of matter, the tetryon, we have a 4 pi geometry, and this is of course equivalent to spherical geometries of 4 pi. Again, the final note here is that as we bring charges or quantum of matter, tetryons, together, whether they're charged or neutral, into their various combinations, we form larger and larger scale matter. The matter component has mass energies within their charged fascia, but matter is not a measurement of mass due to its coordinate system changes. Mass is measured per c to the fourth. Matter is measured per c to the fourth. Mass energy is measured per c squared. So it's appropriate to say in this case, from the geometry and the coordinate systems, that mass energy is a property of matter, but matter cannot be a property of mass energy. You can mathematically describe it as such, but in the physical sense it is not a property. You cannot make three-dimensional property or coordinates a system a part of a two-dimensional coordinate system. Again, all the properties, all the physical properties, of charge, mass, energy, momenta, etc., are exactly the same as they are currently formulated in the standard model. The only major difference obviously being the equilateral geometry foundation. And of course in Tetrionics we can now explain what charge is, and that is it's the geometry that's created from mass energies as a result of the equilateral charge field. Even though there are square energy momenta or frequency of quanta within this charged geometry, the geometry itself is invariant, so as we add more and more quanta to the field, it will always have the same charge, and that charge is the result of the imbalance of positive and negative quanta within that charged geometry or equilateral geometry. I encourage you to cut out individual triangles of positive and negative quanta, 0-point fields, and add them together in various combinations that you care to think of, in which case you will find that in the case of all two-dimensional fields that you create, you'll either have bosons or photons, or at the most extreme you'll have a single charged boson, an equilateral geometry with many positive and negative charges, but they'll always add up to be either a net positive or a net negative within that charged geometry. You will never get a neutral. This again harks back to the geometry of Planck's constant itself. And it's this geometry again that gives rise to positive and negative charges. If we seek a neutral charge, we have to combine a positive and a negative together to obtain a neutral, and that gives us our electrostatic and magnetostatic fields. Again, with Planck's constant, always positive or negative charged geometries, and the charge of any field is the result of the imbalance of the alphas, or the quantized angular momentum or geometry of the energy quanta within those fields. You seek a neutral, you need to have two, a positive and a negative, coming together. If you had two positives coming together or two negatives, you would create an electrostatic field. In the case of the photon, the positive and negative come together to form a magnetostatic field, although in this case it forms a photon of light, and as soon as it's created it radiates bilaterally out in both directions. So charge itself, whether you draw it in its true form of an equilateral geometry, it's alpha, or whether you indicate it as a flux of energy within the 0-point field of the geometry, makes no real difference. Electrical engineers like myself, I found it particularly easy to understand the physical properties in terms of this vector rotation of energy within a short-circuited inductor, particularly when it comes to moving matter through external EM fields. and explaining inertial mass as we did in the previous lecture. But in reality, these vector rotations do not exist. To call angular momentum a vector rotation now within physics can only be done on the macro scale. If you wish to refer to angular momentum at the quantum level, it should always be referred to as quantized angular momentum, or alpha, because it's an equilateral geometry. There is no vector rotation. And again, it's the imbalance of positive and negative quanta within any charged geometry that creates the net charge of that field, and it will always be positive or negative, never neutral. Wherever you see a neutral, you know immediately that it's resulting from a 2 pi or an even number of quanta, photons or EM waves, for example. You may be tempted to think that the Planck quanta itself is neutral because you can't measure the charge. There's a positive and a negative on either side, but in fact you still have the magnetic dipole arrangement, which is emphasized in the case of a Planck quanta, and may in fact be interpreted as a basis for string theory, where you cannot measure the electric fields, but you can measure this point of finite length magnetically as a magnetic dipole. And if you re-express or reword string theory to be dipole theory or magnetic dipole theory, many of the properties it's attempting to describe mathematically in the way of different arrangements of strings within for each particle can of course be expressed as simply different arrangement of dipoles within equilateral geometries of Tetrionics. The only difference being obviously that Tetrionics shows the physical geometry of the fields of energy and of all the matter geometries that they can create. And in this particular lecture, we're now describing not only fields of force that they can create through their energy momenta, but we're describing how this equilateral geometry, or the alpha, gives us all of our constants. Charge is our very first, equilateral geometry is our very first constant, which is alpha, and charge is the first one to come out of that as a measurement of alpha per unit of time or spatial coordinate system. Wherever we have charges, or magnetic dipoles particularly, we specify it as a charge. The north-south arrangement is a positive charge field, or a positive E field, and a south-north arrangement would be a negative E field. Note in both cases, the real physical reality here is that the E field has no polarity, no direction of flux, nothing to distinguish it a positive from a negative. What distinguishes the positive and negative E field momenta, or energy, permittivity, from the different charges is the arrangement of the dipole. It's the north-south arrangement that tells us that this will be a positive charge, and in fact it is what makes it the positive charge. If this dipole were reversed and this electric permittivity did not change at all, if that was possible, you would have a negative charge. So it's not really, even though it's measured as a different field force, or a different effect, or a different force resulting from the electric permittivity of a field on a charged particle as it moves through it, as we discussed in the previous lecture, the energy momenta and the permittivity does not actually physically change. What changes is the quantum dipoles. And again, there are no magnetic monopoles. The equilateral geometry tells us quite clearly, as per Gauss's law and Maxwell's laws, that wherever an electric field exists, there exists two magnetic poles, or a dipole. And again, the dipole, even though it has the same energy momenta content as the electric field, has a different equilateral geometry. Permittivity fields are diamond-shaped. Magnetic dipoles are equilateral geometries separated, or 2 pi geometries that have a separate field or separation. Of course, we can measure the electric and the magnetic properties of these fields in terms of their energy momenta within each geometry. And we'll see that there are not only differing force vectors, but there's differing strengths due to their geometry, and this gives rise to the term permittivity for the electric field and permeability for the magnetic. The permittivity is measured in terms of Coulomb's force and expressed as such, and the permeability is measured via the Lorentz force between charges in motion, most notably, but it's the same force that you experience when you try to bring two bar magnets together. We can combine these, the permittivity and the permeability constants and fields for the energy momenta within an equilateral geometry of charge, and we find that it gives us a value of 1 over c squared. Again, it's the inverse of the radial geometry created by the propagation of energy, or in this case photons, within the field. We've measured it using a photon, the speed of light for a two-dimensional field of energy momenta. We've measured it using light as our constant. We need the two directions to create our spherical geometry. If we were only measuring the linear momentum of the system, or the linear forces, we just divide that by c as we do in physics and get us back to our vector measurement. However, in this case, permittivity by permeability gives us 1 over c squared, so we show in this case that this pi charge geometry of an electromagnetic field, or electromagnetic mass energies, is the inverse of c squared. And again, Maxwell calculated this out when he combined Gauss's and Faraday's laws of electric and magnetic fields. Got the value here, divided that by the square root, or took the square root of it, as we do in physics, to give us the linear momentum. Again, you could have done the same thing with the field of energy, the scalar field, dividing by c to give us the linear momentum. Two different mathematical approaches to the same result, geometrically. But in doing that, he obtained a specific velocity, which again is expressed in the geometric relationship. As you increase the energy within any charge geometry, you increase the energy momenta, so you change the velocity in relation to the square of the quanta within the field. This velocity that he calculated for mathematically is in fact the natural velocity of energy, and that's why I chose to represent this with a charged geometry, a boson, rather than a photon, because it shows quite clearly that it's the square root of the scalar field and its energy momenta that gives us the natural velocity of energy in any medium, or in a vacuum it gives us the speed of light. Of course, you can work it the other way. If you know the velocity, you can square the velocity to get the energy momenta quanta multiplied by Planck's constant to get the energy of the field, and knowing the Compton frequency, you can calculate the wavelength of the Planck quanta within that field, and of course that's multiplied by 2 is the frequency of light. Again, within a charged geometry, it's better to measure it with Planck nu rather than 2 Planck nu, which is the measurement of photons. Again, bosons are transverse measurements, so in that case you will be measuring the transverse or Lorentz forces, the quantum levels within that energy field. If you took measurements of photons, or measured it via the oscillating positive and negative E fields, which is how you measure photons, you're in fact taking a longitudinal measurement of the energy distribution within that field, and that of course can give you the probability mechanics of wave functions. Either approach is completely valid, and in fact in early textbooks prior to the turn of the century you'll find a lot of discussions on transverse and longitudinal masses within EM fields. Of course, in both cases nobody realized what the true geometry of these fields were, and in fact Einstein formulated relativity on the basis that you would never catch a photon in order to see what it looked like. Tetrionics obviously disproves that in a geometric sense, and then goes on in previous lectures within these lecture series to show that relativity was based on erroneous assumptions and can now be replaced with Tetrionics. Looking at the E-field permittivity of the EM field, they are distinct descriptions of the same geometry, of similar geometries. The EM field obviously is the total electromagnetic field. The E-field permittivity is the diamond-shaped electric component. This is the component that oscillates between positive and negative as we measure it to accelerate electrons or other charged particles. This is how it's normally described, and in fact it's the best analogy we can have. The sine wave component, as done in other lectures, and I'll cover briefly here, as you move through the equilateral geometry, you go from a 0 point of E field, and as you move along it increases in width. So the strength, the number of energy momenta per boson is increasing, or the energy momenta per quantum level increases till you reach a maximum here at the center, the widest part of the geometry. This is the area where you have the most energy momenta within the bosons. You can measure it in terms of bosons. It might be energy level N8 back to back with another N8, or if you measure it longitudinally, as we normally do with the E-field permittivity, you would measure them as two bosons back to back, N8 energy levels, or a N8 energy level photon. But in either case, this is the region where you have the maximum energy momenta within the E-field permittivity. At this point, as you progress, it begins to drop back down to zero for whatever charge it is that you're measuring. Same thing happens here. As the E-field starts to drop back down, the specific orientations of north and south magnetic poles ramps up due to its boson mass energy momenta content. It's the geometry, this diamond shape, that tells us that it's an inverse squared law and that we're dealing with the electric permittivity. Again, magnetic fields, magnetic poles also follow an inverse squared law. They're half fields. If we have a magnetostatic or a photon, it would then form a photon of magnetic field. Again, it would follow the inverse squared. But if you measure the entire dipole, and this is the, I think it's pronounced Biot-Savart law, you will find that the dipole measurement is an inverse cube law as it radiates out, because the geometry of the dipole is a tau or 2 pi geometry, a sawtooth type geometry, completely distinct from a diamond geometry. And this 2 pi geometry is an inverse cube law. This is discussed again in other lectures available on the channels. But we can measure these forces and we can get a constant for the electric permittivity. And in fact that's what's done. It forms the basis of Gauss's law and can be re-expressed mathematically in a number of ways. Care should be taken with the constant here, because even though it has the same geometry, an inverse squared geometry, as the gravitational constant, it is in fact the result of a different force mechanism. In the case of Coulomb's constant, the electric permittivity constant, it's the result of superpositioned 2 pi fields. So 2 pi for the electric field on top of 2 pi to give us opposing energy momenta will give us a 4 pi electric field. Again, you have to visualize 2 pi on top of 2 pi. So 2 by 2 gives us 4 pi of electric fields. And of course we're talking about what's inside the electric fields. Only the particles that move within the electric field feel this force, or if this force is between two charged particles, it generates the energy momenta, linear energy momenta, creates the force. And it's a slightly different mechanism that creates the same force and the same formulation, mathematically, for Newton's laws. And again, this is discussed in great detail on a many number of other lectures as we delve into general relativity and disprove it. But it's the geometry in this case that's giving us both the 4 pi and the permittivity, or the definition of where the E field lies within the mass energy geometries of physics. It also gives us the inverse c-squared geometry of charge. It gives us the c-squared or c to the fourth spatial coordinate systems. And it also gives us the net charge on all matter itself. Here we have back-to-back negative and positive E fields forming an electrostatic field. You'll note in this case the magnetic dipole is neutralized. It is still there, but because you have a north-south pairing, any attempt to measure this dipole or even the polar fields at either side will not produce a result. You bring a south pole in, the north pole will be attracted, but at equal strength the south pole will push away. And this creates a neutralized, not completely neutral, because obviously you still have a distance relationship, but for most measurements that we can do on the macro scale of quantum particles, it's neutralized. In which case all you can do is measure the E field effects. Of course the E field is determined again by the geometry and the dipole arrangement of the magnetic fields within the charge. We can draw this more correctly than it's currently drawn by simply showing a point particle with negative divergent fields and positive convergent fields for a negative electrostatic field. Or for a positive electrostatic field, we draw it with positive divergent fields of force and negative convergent. And this is where we get the term law of interaction, which replaces the old terminology of law of attraction. Each field, irrespective of its charge, will have attractive and repulsive or convergent and divergent energy momenta. And again, the strength of the momenta is determined by the number of quanta within the field, and the direction of force, net force, is simply the square root of the field, which is again can be interpreted as the integration of the square roots of all the quantum fields. Any charged object moving within these fields of force will experience a force, and the strength of that force is determined by the energy momenta that are present and by their geometry. So again, geometry forms the basis of Coulomb's force and other forces. Looking at the magnetic side, the electric side was obviously a measurement of Coulomb's force. With the magnetic fields, or the permittivity, permeability of the EM fields, we normally refer to it as a Lorentz force. It's a transverse force between magnetic fields or magnetic dipoles, depending on what you're measuring and the scale of which you're measuring. You could, of course, interpret this as a 2 pi equilateral geometry that is distinct from the diamond 2 pi geometry. They're both 2 pi geometries, but they have distinctly different geometries, giving us the properties of permittivity and permeability. And again, there's always a dipole, never a magnetic monopole. You might measure a single pole, but even a single pole will have two poles associated with it. It'll either be a magnetostatic field with two charges, or it'll be a Planck's quanta. If you could measure one free and by itself, you would measure a strengthened magnetic field with the result of a north or a south pole orientation either side. Again, it just gives us a slight, if you take away the permittivity colouring for the fields, you get a inverse squared law, as I discussed, for the magnetic poles. Each north or south pole is a diamond shape, so it's an inverse square. However, measuring the dipole gives us the sawtooth transverse orientation of the fields. We measure the Lorentz force in a various number of ways, but it's always comes back down to a measurement in henries as it's been determined. and it's just a measure of the energy momenta within the specific geometries of magnetic fields as they form up. Of course, in Tetrionics we use this dipole arrangement, or the geometry of EM fields, or energy momenta, as a shorthand for determining Ampere's law, etc. And not only does it give us a quick reference for the strength of the fields, it also gives us the magnetic fields for charges in motion generated by their kinetic or their chem fields. And again, in the case of magnetic fields, the permeability is determined by the geometry. 4 pi is determined by the overlap of these two pi fields, where you get two particles interacting transversely or laterally instead of longitudinally. As they come together side by side, the fields will overlap and interact, and where they overlap is a 4 pi field. Doesn't matter if it's only a fraction of this 2 pi field. If a fraction of it overlaps with another one, it's still a 4 pi field. Within that geometry, we would then scale up in proportion, in relationship or in proportion to that 2 pi to give us the rest of the field out here. But the field of interaction would be a 4 pi field, whether it's a small part that overlaps or whether it's the whole field. And we can use these geometries and these strengths to give us all the calculations for the magnetic forces of charges in motion. And again, you'll see that it's always a unit of force or vector direction of force within a geometry, or a measurement of the geometry, the charge. Obviously we've just discussed two ways, two different or two similar geometries that can come together from a single charged or alpha geometry. And the two geometries that result are electrostatic and magnetostatic fields. Again, you can see how in the case of photons or opposite charge pairs coming together via the weak force, we create a diamond-shaped geometry and a strengthened magnetic dipole. So this is, in the photons case, this is a perfect description and geometry of the photon itself, with its equal strength electric and magnetic fields that are orthogonally opposed to each other. And if the wave were to move towards us out of the page, it would be a transverse field, with the direction of energy propagation being transverse to its direction of motion. Or if the photon was propagating along the page in the same plane, it would be a longitudinal photon of energy. Two fields can result from quanta coming together, or charged energy momenta coming together, and that is either an electrostatic field, because the linear momentum cancels out to create no motion, or where there is no material point here, and obviously no particle to accelerate, the field itself of electric and magnetic energy is free to propagate at the velocity of energy, the speed of light, in two directions from its point source, or its source of creation. As it propagates out under the inverse squared law, as the measurements of time increase or the distance increases, the field itself weakens as the square of the distance. This picture here simply shows that in the case of electrostatic fields, we can have positive and negative energy momenta within those fields that will affect particles that move within them. And again, it's an inverse square field. The strength of the force is stronger where you have more energy momenta per quantum level or per boson, and that's always at the source of the field. And all matter, even if it's neutral, is made up of charged fascia, positive and negatives, and they all possess electromagnetic fields, whether they're an electrostatic field of charge that can affect charges, or whether they are a field that is termed black body radiation is irrelevant. In both cases, they're an inverse square field. What changes between electrostatic and black body radiation is simply the number of quanta of energy momenta within those fields. Obviously black body radiation is weaker, whereas the electric force of electrostatic fields is much stronger. But they are all the same. These fields will emit light as described by Planck's law, E equals nh nu, and the light they can release is determined by the changes of energy momenta, so the strength of the bosons that are released from these equilateral geometries. And again, Rydberg's formula, although mathematical, is completely described as energy changes between square energies within the equilateral alpha geometry of charge. Highlighting how energy momenta form imbalances or charges within each fields, and these fields create electrostatic fields of acceleration or fields of force, is shown on this page. You can see in the case of a negative charge there are more divergent negative energy momenta than there are convergent positive energy momenta. And in the case of a positive charge field there are more positive divergent energy momenta than there are convergent negative momenta. But the result is the same. If a positive charge moves within the field of force or interaction of the negative charge, it will be accelerated as per the positive charge energy momenta. They will act upon it to accelerate it towards the negative charge. However, if the same positive charge was to move within the field of force for a positive charge, it will be in fact acted upon, will be opposed, and be firstly slowed down or decelerate and then be accelerated away. These fields and these geometries of energy momenta are what Richard Feynman was trying to describe when he said, although QED may be mathematically beautiful and in his claim very accurate, it does not explain how each particle knows where the other particle is in order to act upon it at a distance. The electron, as he put it, does not have a supercomputer doing the mathematical calculations of what the strength is and what the charge is on the distant particle and all this, and that would of course violate transfer of information as well. All this interaction is done through the equilateral charged geometries of energy momenta between the particles. These fields radiate out from particles, be they charged or just block matter, as either electrostatic or blackbody radiation. Charged objects or objects in general moving into these fields will experience forces upon them determined by their charges, their mass energy content, and the strength or the number of EM quanta, energy momenta within those fields. This is what's doing all the work, all the calculations, allowing one particle to know where the other particle is and to act upon it appropriately at great distances, almost instantaneously. It does it via a longitudinal force of energy momenta, and the force increases as you get closer to the particles. There are no magical calculations to be done. Where the maths comes in is where we as humans attempt to describe the underlying geometry or the alpha of these fields and the energy momenta within them. What's represented as an entire field of quantum electrodynamics is represented on this page as simple alpha or equilateral energy geometries. And in this page even shows Ampere's laws and Lorentz Forces using the stylized models that you see here for charged particles in motion. So Tetrionics from a foundational geometry gives us everything that entire fields of mathematics attempts to describe. Where it's superior to the mathematics is in its geometry itself, because the geometry is rigid and will only allow certain operations and interactions to occur. Where the mathematics differs from what the geometry is showing you, rest assured that the geometry is always right. And it's the mathematics that's in error, either through the way the operation is carried out, the calculation itself or how it's describing the underlying geometry. Again, the investigation of physics has been on a mathematical basis for the last 200, 300 years, and that mathematics has been attempting to describe and derive what the underlying geometry is. Tetrionics now gives us that geometry, and we can work in the reverse direction to refine the mathematics and correct it. So the law of interaction, the fields of force, what gives rise to the forces themselves and their constants, is simply the result of the geometry and the energy momenta within that geometry. As we change the energy momenta for either field, we change the strength of the force. Particular particles will radiate certain amounts of energy naturally due to their mass-energy geometry or geometries. Some are more efficient at generating fields and energy within those fields than others. The electron, although it has the identical charge to the proton, -12 versus +12, is in fact far more efficient at generating EM fields of force than the proton is. So for a proton to create a similar field of force to the electron, you'd have to accelerate it or increase the energy momentum within its field greatly, about 2,000 times. Again, the difference is reflective of their inertial mass of the matter geometries, 2,000 to 1, roughly, 1893 I think it is, or 1895. All these forces created by these equilateral energy momenta within the specific geometries of the two-dimensional fields, where they superposition and interact, gives us Lorentz's force. As I've just described, it's determined by the strength of the electric field and the velocity, along with the magnetic field interactions. They're just transverse versus longitudinal measurements, E versus M, permittivity versus permeability. They're all different ways of describing equilateral geometries. Gauss obviously described it as the squaring of the field and measuring it via its electric field, the total energy content, and stripping away the electric field in this case, giving us our familiar law of interaction. There are many different formulations, but there is only one geometry. This is the geometry that the dozen or so formulations of Lorentz and Coulomb's force laws represents. In both cases it's an inverse square geometry, and in all cases they're the result of equilateral geometries of mass energy momenta. So we've now clearly defined and distinguished between mass as a two-dimensional energy geometry per unit of time. Energy without a unit of time is just purely energy, and matter, of course, is a three-dimensional standing wave of energy, which comes together to form larger scale matter geometries. In the case of mass energies, we measure per c squared to give. In the case of energies, we measure per c squared to give us mass energies equivalents. In the case of matter, we measure per c to the fourth to give us matter energy equivalents, or if we measure per c squared, which we can, we get mass matter geometry equivalents. But in all cases, again, it's the equilateral geometry of energy, or Planck's constant particularly, that gives us the constants of electric and magnetic permeability and the constants of force. It also gives us the relationship between mass energy and momenta, or mass velocity, within physics. Tetrionics obviously has the unified field equation, and we use that to express mass, energy, matter in all its forms, where energy itself is simply mass alpha, or Planck's constant nu squared, or mass velocity squared. It's either the quantized perspective you're looking at, or it's the classical perspective. Either way, m alpha v squared describes the energy in either formulation. The n pi geometry obviously gives us the clue that it's a mass energy or Euclidean two-dimensional measurement of mass energy. Where you see t pi per c to the fourth, you know immediately it's a spherical coordinate system, so the t stands for Tetrionic geometries, so there must be 4n pi standing waves of energy. Of course, we can expand this out further by adding electric permittivity and permeability to the formulation of the unified field equation, which changes these formulations to indicate whether we're talking mass, energy or matter within mass, energy or matter itself. There is a distinction between kinetic energies and momentum itself. The kinetic energies are half mv squared, or they are either electric permittivity fields or magnetic permeability. Normally expressed in most textbooks as being kinetic energy and magnetic moments. The term kinetic energy referring to the permittivity is slightly misleading. However, this is how it's been developed over the years mathematically, again because there was no understanding of the geometry in the case, and again because relativity expresses the magnetic moment of charged particles in motion as a completely different term, or the reinterpretation of the electric field as a result of its energy of motion. But the kinetic energy and the magnetic moment are of equal strengths and vary according to the velocity, and it's shown now in Tetryonics that they are in fact the result of the same charged field geometry. In this case, the field geometry is the chem field, the kinetic EM field. And again, just for those that are jumping into this lecture without the others, the chem field is where the Lorentz corrections takes place and the mass energy of motion is stored. Matter itself is Lorentz invariant, and as a standing wave it is not affected and has no additional mass energies within its geometries as a result of its motion. All the energy of motion applied by a force under F equals ma is stored in the geometry of the chem field, and the inertial mass simply relates the force applied to the velocity, or the change of velocity, the acceleration that results from that force for that geometry of mass energy or inertial mass matter. Accordingly, where we're talking about chem fields, we should highlight E equals mv squared still, but it's a capital M, which stands for matter, not mass. Actually, it stands for mass matter, the inertial mass of the matter geometry concerned, because the force, the acceleration produced by the force, is proportional to the total inertial mass of the matter. In Tetrionics, because we define mass distinct from matter, instead of lumping it in all together as energy, as they do in relativity, we define matter, or the tetrahedral standing waves, with a capital M in all cases. Where we refer to the mass of the matter, we would do a small m for mass, and we would colour it green to indicate it's the mass of the tetrahedral matter geometry we're talking about. If you saw matter as a small m with a blue, you know again that it's Euclidean mass energies that we're referring to. These are distinct formulations for mass, energy, matter within Tetryonics, and they have to be followed in order to distinguish between mass and matter. The only other way to objectify and distinguish between them would be to re-term mass or matter as something different with a different letter in the English alphabet. However, centuries of physics that would create a problem, to say the least. And again, whereas we've now described kinetic energies, which is what Ke always stands for in Tetrionics now, as a half mv squared, be it electric or magnetic, you just simply specify which you're referring to. The linear momentum of any system is the result of the square root of the total energy within the scalar field. Again, it's the geometry of the energy field that allows only square numbers to be included per energy level. And in order to increase the velocity, which is the square root of the energy momenta, we have to increase it in odd-numbered bosons. But in doing so, the square root obviously has a geometric property as well. That is the height of the equilateral triangle. So where you see the height of an equilateral triangle, you know it's the square root of the scalar field. We're talking the linear momentum. The kinetic energies can be electric permittivity, diamond-shaped fields, or triangular fields, which are inverse squared forces, or produce inverse squared forces, or the dipole, which is a 2 pi geometry, which creates a inverse cube force. Of course, all this relates back to the equilateral geometry, the alpha, or the quantized angular momentum of the field itself, its charge. And in the case of chem fields, they'll either have a positive or negative charge, and that's determined by the net charge of the particle in motion. All of these formulations for energy, mass, matter, electric permittivity, permeability, and their constants, energy, force, inertial mass, the Lorentz factor itself, are all derived now from the equilateral geometry of energy, or Planck's constant, mass alpha. Of course, if you want, you can convert between mass and energy, alpha and charge, etc. These formulations are just the tip of the iceberg, as we've discussed in previous lectures. But in all cases, they're subject to Lorentz corrections if we change either the velocity or the energy momenta within the equilateral geometry, or the charge. If that varies in any way, they are all affected by each other. What remains invariant, obviously, is the quantized angular momentum per c squared, which is the charge. So again, Tetrionics shows via its geometry that charge is Lorentz invariant, or does not change as you change the velocity of any particle. You do not get any change in charge. Again, it shows that mass energy is invariant, or actually it's invariant where you have stationary fields. It has a Lorentz factor where you're accelerating things. As you change the velocity and acceleration, you must change the energy momenta within the chem field. So mass energy is a Lorentz variant within chem fields. Within matter itself, it's already propagating at the speed of light in a standing wave, and it's not affected by any changes. The mass energies of the matter, or the standing wave geometry, do affect how efficiently any particular force can affect an acceleration or a change in velocity. And that, of course, is F equals ma, or Newton's formulation. And of course, we replace any attempt at geometry in relativity by mathematicians, where they've used right angle triangles for these same values, for kinetic potential, for momentum, energy itself, for mass and matter. We replace all their right angle triangles with equilateral triangles now, because it's the alpha geometry that is the key to physics. And as I said, any changes in energy momenta that are required via the application of a force on any mass matter has the energy of that force stored in its chem field. Whether you're measuring energy and quantizing it to get the Compton frequency, or whether you're measuring the scalars to get the velocity or the acceleration that occurs for the energy momenta within that field, makes no difference. They all produce a corresponding Lorentz, or are subject to a corresponding Lorentz correction. However, again, normal mathematics will highlight and indicate that it approaches infinity as you approach c. This is not the case. It approaches c, the quantum level before the speed of light, or the natural velocity of energy, will in fact be c minus 1 for the boson, or the number of Planck quanta within the boson. You then add C plus 1 in a energy momenta in a boson of charge to this geometry. You will compress or shorten the wavelengths to add the energy, and the resultant energy momenta, linear energy momenta, will produce a velocity that is superluminal. You can still use the same formulations, except instead of 1, which represents c squared on c squared, or the scalar field, you would in fact have an imbalance, just like you have here. And it would in fact be it'd be a continuing curve. The curve continues, it does not stop at C. It just requires more energy. As you increase each velocity or each integer number, the square root, the velocity if you like, from 1 to 2 requires more energy. And it requires more energy again, because it's an increase in odd numbers, to reach velocity 3. Velocity 4 requires even more energy, and it's less efficient at creating the velocity. This is no different than a drag racer trying to go down a time trial, and his speed is, say, 16.01. While it's easy enough to get to, say, 16.01, it is immensely more difficult to accelerate that same engine and everything else to, say, 15 seconds, or have a time result of 15 seconds, because considerably more energy has to be inputted for a smaller gain. And this continues all the way through, following this equilateral geometry. Force equals ma. As you try to go faster and faster, the energy required increases more and more in odd number boson quantas. But it never stops. You can in fact go superluminal. And that's what this geometry is showing us. Whereas the mathematics without the geometric base simply assumed that Einstein was correct in his assumption that the speed of light is a constant, and set that as a limit. There is no limit to the geometry, apart from the fact that there are no infinities. Every number is a finite number. And this is what we show here. Within any charged geometry of mass, energy, momenta, the geometry itself is the inverse of c squared, which is the electromagnetic properties, permittivity and permeability. The square root of that is the velocity that the energy will propagate at, in this case the natural velocity of energy, or the speed of light. This velocity will of course change dependent on the frequency wavelength relationships, and the medium that this energy is propagating through. But if we determine the electric permittivity and the magnetic permeability for these fields of energy momenta, we can calculate for the velocities of any field of energy. Of course, using the geometry, we can then specify the difference between radiant charged energies and photons of energy. We can distinguish between longitudinal and transverse measurements, and more importantly, we can define what mathematical operations are allowable or appropriate for physics. As we've discussed, rest mass matter, or mass energy matter, is invariant. It's formed up of a standing wave geometry of tetronic particles of matter, and we measure it in spherical coordinate systems. So it's the energy, in the case of matter, it's the standing wave energy content per spherical coordinate system. In the case of mass energies, within chem fields, for example, or photon EM waves, or electrostatic fields, magnetostatic fields, we measure it per c squared for a spatial coordinate system, because it's a two-dimensional Euclidean property of energy. So mass is just a measurement of energy per second or per c squared coordinate system. This of course quickly shows that mass as a c squared coordinate system is a property of matter, but matter as a spherical coordinate system is not a property of mass. But they all have properties of energy. So where we're measuring a physical system in motion, and the forces it produces and the forces within it that create it, we can term the entire energy of the system, irrespective of whether it's energy, mass, or matter in its waveform. We can determine it as a relativistic energy. We can obviously measure the mass content of that energy through Einstein's equivalency formula, but more importantly, we can measure, exactly as Einstein measured with his stress energy tensor, the entire energy differential within this volume or region of space, this coordinate system, for any velocity, and we can calculate the changes of that total energy density in relation to changes of velocity or acceleration. Again, Tetrionics takes all of this from the general energy density of stress energy tensors back to mass, energy, matter geometries. Again, it's the geometry that's key, and it's the geometry that gives us the information about the invariant properties, velocity invariant properties of standing wave matter, along with their charge, mass, energies, etc., and gives us the same similar properties for mass energy for the chem fields of the accelerating particles. In which case we can now talk about mass energies of chem fields and permittivity and permeability in terms of mass and mass energies. Tetrionics allows us to define all of these properties in various ways to give us the final result that Einstein used in his stress energy tensor. But again, the geometry is showing us what the mathematics cannot show. And the geometry is correcting the errors of relativity that were developed A, from using a stress energy tensor where all energy forms are lumped together, and B, from the erroneous assumptions of what creates the magnetic moment of charged particles in motion. In which case we clearly show that it's the Lorentz contractions of mass energies in the chem field, not the contractions of mass energy matter within the stress energy tensor. This is a clear distinction between relativity mathematics and tetrionic geometry. And as we said, we can quantize these scalar fields, or the chem fields of mass energy, that produce a specific momentum or acceleration, and we can use this quantization through Planck's constant to give us the quantum mechanical properties of classical physics, in which case h nu squared equals the scalar energy momenta of the field created by mass velocity squared. This is the quantum formulation. This is the classical formulation for the same energy within the chem field. In both cases, they're just forms of energy. One's mass, the other one relates to Planck's constant, which of course we've shown to be mass alpha. And in doing so, we show that it's a geometric measurement of energy momenta. Of course, we can then reterm the classical and the quantum to mass alpha nu squared for energy. And that's what we do up here, where we want to specify the energy as a electromagnetic mass. We simply do so by dividing by c squared for the electric permittivity and the permeability of the energy field. This gives us electromagnetic mass velocity versus an EM field of Planck quanta squared in both cases. We're now showing the relationship between mass, energy, momenta, and geometry with the unified field equation. And we're showing that externally it's the net geometry that determines whether it's matter or mass that is formed. So as we state here, electromagnetic mass is clearly defined to be the measure of the total energy density of any coordinate system or space-time geometry. Whereas matter is any mass energy, as previously described, that creates a three-dimensional standing wave or tetronic geometry. i.e. it folds up to create three-dimensional mass matter or mass energy matter. Again, mass, energy and matter are all related to each other through the square of the speed of light, or if you wish to refer as mass, energy, matter, momentum, as a complete physical description of the any system, any measured region of space, or any region of a coordinate system. They are, of course, all related through the speed of light, or the square of the speed of light. The speed of light will give you the momentum measurements. The square will give you the mass matter measurements for energy. But in all cases, it's geometric. Accordingly, one of the final points for this page is that we should drop the term massless from all physical textbooks. Where there is energy, there is mass. E equals mc squared. Mass is just a measure of energy content per unit of time or coordinate system. So therefore, wherever you have energy or something to measure, be it mass, energy or matter, you have mass, or you have the energy equivalent. So the term massless no longer exists. Where it has referred to massless photons as an expression of their inertial mass, for example, they should be retermed to either matterless particles, reflecting that they don't have a three-dimensional component to their geometries, or accordingly, if you're talking about photons being massless, particularly in reference to general relativity or gravitational fields, you should term them as being matterless or weightless. Many people will now jump up and down and say, but gravitational fields bend light. Gravitational fields do not bend light, or gravity does not bend light. The bending of light in a gravitational field is the result of electromagnetic interactions within that field, with the gravitational field being the result of gravity plus electromagnetic interactions. Again, this was completely missed in Einstein's formulation of relativity, because he failed to acknowledge or distinguish between mass and matter firstly, and secondly, by lumping all forms of mass, matter and energy and momenta into a stress energy tensor, he then failed to correctly identify the quantum mechanics at work within the gravitational fields that created his energy density curvatures. Tetrionics does all of this through the geometry, and again shows or corrects many assumptions of relativity and mathematics through the use of geometry. In the case of distinguishing between matter and relativistic mass energies, or relativistic energy of motion, Tetrionics firstly shows that point particles of charge are not spherical point particles. They are n-pi or t-pi charge geometries. In this case, we have an electron, which is described as an elementary charge of 1 in quantum mechanics and QED. In Tetrionics, we now describe it as a 12 pi or a negative 12 pi standing wave mass energy geometry. It's a complete description of the charged particle that is an electron. It gives us the charge, its physical properties of permittivity and permeability. It gives us its inertial mass for its matter geometry, and shows us many other properties so far as charge mass ratios, etc. We can define this using the Tetrionic unified field equation for energy, excluding the permittivity and the permeability properties. We just show it as a standing wave energy geometry in this case. When we accelerate it, we obviously add an additional field of energy momenta, the chem field, to this geometry. And for any force applied, the mass matter will produce a certain number of quanta and that will produce a distinct velocity or a change in velocity and acceleration. Again, Newton's F equals ma. And again, noting here we specify kinetic energies as being a 4 pi mass energy geometry. It's not green in colour, it's blue, indicating it's a 4n pi, as in Euclidean mass energies, and then neutral. So we have 1, 2, 3, 4 pi geometries. 2 pi of permittivity, 2 pi of permeability. And of course the permeability forms a magnetic moment, an Evans magnetic moment in the case of photons of light here, or in the case of the matter that's in motion here, it would be a Bohr magneton. But adding the kinetic and the magnetic fields together gives us the scalar chem field. Again, it's a equilateral square energy field, and the geometry places physical constraints on it so far as the electric and the magnetic field properties and the charge geometries of energy momenta, divergent and convergent within them, which then again when they interact gives us fields of force, or Coulombs or Lorentz Forces. We can add the standing wave mass energy matter geometries together with the mass energy momenta within the chem field, which is Lorentz variant according to its velocity, and that will give us a model of the mass energy density, or the energy density within Einstein's relativistic stress energy tensor, tau, or I think it's tau, TAB, tau AB. What Einstein's stress energy tensor is describing is purely the mass energy, or purely the mass, the energy content of this geometry, but it does so with respect to c to the fourth, so it smears or spreads the mass energies out within that spherical geometry and assigns them a density as it does in QED with the wave functions. Tetrionics takes all of this generalized information of QED, QM, and Tetrionic math, relativistic math, and gives us discrete, defined geometries and physical properties for mass, energy, momenta, and the forces that it can create. All these forces, as we've discussed in previous lectures, then combine, interact, superposition. We can separate the electromagnetic fields, the charge geometries, the alphas, to give us charge fields. We can add energy momenta to these fields. We can fold these fields to create matter, charge matter geometries. As we add energy momenta, we not only increase the inertial mass of these matter geometries, if we separate the charges, we can create fields of voltage that can provide an EMF through their energy momenta. Where these fields overlap, we create fields of force. In the case of Coulomb's law, it's an electric field of force that's created. In the case of bar magnets, we're creating Lorentz force, magnetic forces, or we're experiencing magnetic forces from the superpositioned energy momenta. Obviously, where we have charges that are separated with energy or energy momenta within those fields, the voltage depends on how many energy momenta are within it. There's always a square number. But we can connect these separated charges via a conductive means, and it will allow a current, or it will create a field of electricity in the conductor, which will eventually create a current flow of charged particles in one direction or the other, again dependent on their charge within the electric fields. Obviously, if we don't connect these two fields up, or these potentials up, with a conductor and allow them to build, increasing the energy momenta, eventually we will reach a point where there's sufficient energy momenta for them to reach out and try to equalize under the second law of Tetrionics spontaneously. And this is what's termed the displacement current in Maxwell's laws. It was the final addition that Maxwell made to his laws when he unified electric and magnetic field mathematics. Maxwell viewed the displacement current, as he called it, it's really a displacement voltage, as a stretching of the field until it broke down, when in fact what's happening is we're compressing energy momenta within the voltage, within the fixed equilateral geometry of the voltage, until it reaches sufficient energy momenta to break down and reach out as it tries to equalize. Again, whether you're determining it as a leap of voltage across or a breakdown, a sudden dispersal, makes no difference. What's important is the geometry that gives you these answers. And of course, once the electric field's established, any charged particle within that field of energy momenta or electricity will be accelerated due to the force applied to that charge by the energy momenta within the field. And again, whether it's divergent or convergent depends on which pole you reference it to, as to whether one's a sink or one's a source. Again, sink, source, electron flow versus current conventional flow. A lot of this, unfortunately, comes about again because in order to start putting mathematics to the physics, someone had to assign a positive or a negative to the particles in the direction of flow, and that was Benjamin Franklin. He had a choice, a 50-50 choice, and it was an unfortunate choice. He chose the wrong one to give us conventional current, when in fact what we were after was electron flow. Many mathematicians have applied their work, as you can see here, to determine the geometry and the forces, the physical forces that these equilateral energy momenta produce. And as the centuries have gone on, the research has become more and more mathematical. Fortunately, the geometry never changed. What we have now is a situation where, now that we know the geometry of all these energy momenta and their forces, we have to reinterpret or re-educate ourselves on our prejudicial ideas of what the mathematics is describing, and change the mathematics where it's incorrect. Obviously, the chem fields will give us our Lorentz forces and our Coulombic attraction between charged particles, as well as they can describe the electrostatic fields and the blackbody radiation of all matter, even neutral matter. Where these fields, these chem fields and their energy momenta overlap, as indicated here, it creates Coulomb's constant, which is simply the superposition of the electric permittivity of the fields. Again, the geometry overrides the maths. The geometry gives us the math. In the case of Ampere's law of force, very similar to Coulomb's, except he was measuring the current, the flow of electrons, as opposed to stationary electrons. As the electrons are accelerated by the field of energy momenta within electricity in the conductor, their chem fields gain energy momenta and create a dipole. This is completely adverse to how relativity describes it. And again, a quick note that relativity is wrong. There are 3 lectures showing this in detail. The energy momenta of motion gives us the varying chem fields, energy momenta within the chem fields, and the varying magnetic and electric field forces. As they superposition laterally, they give us Lorentz forces. Were these electrons part of a number of electrons in the conductor, they would experience Coulombic forces between the charges of the electrons that would keep them separated. Or in the case of a DC current, would in fact bunch them together to create an efficient charge geometry in of DC current in a conductor. We can of course model all these forces and geometries with the equilateral alpha geometry of a charge, because it's the alpha geometry that gives rise to all these energy, momenta and matter geometries. And as we can use this to model the chem fields and their magnetic pole orientations. So we can see the Lorentz force interactions, and we can see the Lorentz force here and the Coulombic interactions of particles in motion. Again, a lot of these are expressed mathematically with many varied diagrams showing fields of force that don't really exist. They are flat Euclidean equilateral geometries that are interacting. Again, you have this is a two-dimensional representation of three-dimensional forces and fields. Again, we can dismiss all the left and right hand rules for determining directions of force and just use these simple alpha diagrams or alpha geometries. And it's these alpha geometries, or the alpha, the hidden functions, that give us a lot of our mathematics. Well, it gives us all of the mathematics. Some mathematics where it disagrees is obviously describing something that's not geometrically possible. We can give the linear momentum, we can give the quantized angular momentum, we can give measurements of scalar energy, scalar mass, and we can quantize that with Planck's constant to give us smaller and smaller measurements of the energy momenta within these scalar fields. These are all described differently in mathematics and have been brought up and described at different times within history. And we can in fact show that the quantization of energy gives us a measurement of time, or the frequency, the wavelength, or the quantization of the linear momentum within these fields gives us a wave number. Of course, measuring the linear momentum of the Planck quanta within the field will give us their wavelength, physical measurement. And all these units, if you look back at the spectral lines, you'll see that we can again pull apart Planck's constant as mass alpha, kilograms square meters per second, and we can relate all of these measurements of energy, momenta, mass back to the scalar quantized angular momentum, or the equilateral geometry of energy and charge itself. The production of force is probably most noticeable in spectral lines. Again, there's another lecture on it. It's described mathematically using Rydberg's formulation for the wave number, or the number of quanta per linear meter. Tetrionics can show this physically. A lot of debates gone on around people trying to describe to students what a wave number is. You can physically see it here. If the square root was 1 meter, you could physically count the quanta in that meter, and that would be the wave number. Conversely, you could measure the length of one of these quanta, and that would give you the wave length of this quanta, of the quanta within this field. Again, it's the quanta within this field that changes to produce acceleration or changes in velocity. It's their linear momentum and linear length that changes as you add more quanta. You compress them within this field. The energy momenta within the matter again does not change. These compress, they become shorter, so they experience Lorentz corrections for changes in velocity. Again, all formulated mathematically, but never properly described in terms of mass, energy, matter interactions. We can describe the transverse or quantum levels of this field of energy, and we can describe the linear properties of momentum, and we can describe both fields in terms of the bell curve, or the natural distribution of energy momenta within the field, where they superposition, where this field, this chem field, radiates out into space and interacts with another chem field at any direction, the linear momenta of the equilateral geometries of mass energy within the fields will produce a force, either a Coulomb force or a Lorentz force, between the two charged particles. Again, all the mass energy of this field can be stripped down to an energy density and described as a relativistic energy, but it is more appropriate to describe it in terms of its charged geometries of mass energy and matter. All of these things that we've just discussed on all the previous pages in this lecture are in fact rewritten within QED, particularly as a wave function. We can describe it, the wave function, in terms of the transverse quanta or the longitudinal quanta or frequency of photons, bosons versus photons again. And we can do the same thing for the matter itself. We can describe it in terms of bosons or longitudinal mass energies, transverse mass energies, or we can describe it as in terms of longitudinal photons of energy within the mass-matter geometries. These again are invariant. It's the mass energy content of the chem field that determines the acceleration for any given force applied to the mass-matter geometry. Again, in this case, it's the charged geometry of mass energies, the standing wave geometry, that makes inertial mass, which can form a constant when you're measuring force for acceleration. And again, all these numbers, because of the geometry and all the probabilities of finding quanta of specific energies at specific points within these wave functions, are all renormalized, because the geometry is such that we have square numbers and they produce a normal distribution curve from those equilateral geometries. So as we've discussed with in the wave particle lecture, Tetrionics now refers to fields of force as waves of mass energy, and the particles that create them as particles. A clear distinction between mass energies and matter itself. Matter can have mass energies, and it's made up of equilateral mass energies, but mass energy has no property of matter. And again, our universe is only three-dimensional. There are no higher fourth dimensions, etc. within this. Although if you care to, you could refer to the rotational equivalent, or the rotational vector, to describe the equilateral geometry of charge, i.e. the rotation of energy flux within the chem field in one direction or the other electrically, to be positive or negative charges. So you could in fact term this rotation to be a third dimension within the two dimensions of mass energy, i.e. to try and explain that clearly, you could say that mass energy has, and is by necessity, because of its equilateral geometry, has a third dimension in its Euclidean geometry, that of charge. So if you take charge as a dimension, or the geometry of mass energy as a dimension, in addition to its x and y components, when you apply that to matter, obviously you still retain the x and y with the third dimension of charge to the 3D matter geometries. So you could describe matter as being four-dimensional with mass energy charge. Again, Tetryonics describes this as the charge geometry of matter. Three dimensionals of energy within a coordinate system, plus a fourth, that being of the charge within the or the equilateral geometry of energy itself. If you want to know more about this and have me re-explain it in more detail so you can fully comprehend it, feel free to email me or contact me on the net. Of course, within the wave particles within any energy field itself, be it chem or the mass energy fascia of matter itself. It's the distribution of energy momenta or equilateral geometries that creates the fields of force within it, whether it's a force of mass that gives matter its substance within the standing wave geometry, or whether it's the forces of Coulomb or Lorentz forces between particles, makes no difference. Again, it's the geometry that gives us the quanta, and it's the quanta that gives us the strength of the force via the geometry of its interaction. If you measure it transverse compared to longitudinal, you're measuring the same energy quanta, but you're measuring different geometries, which is what gives us the difference between transverse and longitudinal mass energies. But they all relate back to the wave function, or the mass energy distribution of equilateral geometries within a scalar field. We can of course represent the frequency wavelength relationships purely as wavelengths or varying different size energy momenta. As you increase the energy momenta, you start off with a single quanta for a positive or a negative field. You increase it to N2, you would have 4 quanta within these fields. Again, 3 would require 9 quanta. We can either increase the energy within the field in these quanta to create a scalar field, or we can create a scalar field where we have different n field scalar fields, n strength, n squared scalar fields that are superpositioned one on top of the other. In the case of white light, that's exactly what happens. The total energy is not the energy, not a square number where the energy has been added until you've reached a square number within a charge field geometry. It is the result of a number of square energy geometries that have been layered one on top of each other. These of course have different frequency wavelengths for each energy level, and instead of having a normal distribution as there, you have a layering of sorts, so to speak, of different energies. And this creates, for lack of a better description, a fractal wavelength of energy momenta within the charge geometry of a EM field, which is the same as the charge geometry of a photon. These superpositioned specific frequency wavelengths of light all combine to give us white light. And it's when we pass them through a medium that their different velocities of energy, which were the speed of light, change to a different velocity because of the medium, and allows us to refract them into a rainbow. And again, it allows us to pass those refracted colours or separate fields of light back in through the same medium to recombine them back into white light. Again, the energy within white light is no different than the energy within a chem field. The only difference being that the chem field is a discrete squared energy where all the energy momenta goes into motion, whereas in a field of white light or a photon of white light, an EM field, the energy is spread out in a fractal pattern reflective of its constituent colours, not its energy distribution. That's why white light may have similar amounts of energy to the chem fields that produce spectral lines, but the chem fields, the spectral lines, when they combine up together, will produce a stronger motion or produce a force on the electrons within atomic nuclei. Specific colours are required to jump these quantum levels, whereas white light may contain that. It's more likely that a particular light frequency will be required to match the next quantum level step that's required to accelerate the electron. Of course, we can extrapolate this out using the geometry of kinetic energies, half mv squared or mv squared for the total field, and we can show that in the case of Tetrionics, there is no limit to the velocity that you can accelerate matter to. All you require is sufficient energy per unit of time. This in turn will create sufficient energy momenta to accelerate the inertial mass matter to the velocity under F equals ma. So this of course flies in direct contrast with Einstein's speed limit of c. It also gives us the physics that NASA should be following when they make announcements such as, we're going to invent the warp drive. Without this geometry and this physics, they will never create the warp drive. And in fact, the idea of using antimatter matter to drive it is incorrect as well. The time taken to create the antimatter, the resources need to store it safely, and then to release it in a controlled fashion are just impractical. Tetryonics will give us a completely different way that is just as efficient as matter, antimatter annihilation, and in fact we'll use matter energy conversion to power the warp drives of our future starships. And again, this energy, we will simply convert matter into a sufficient amount of matter into energy to fill this field of kinetic energy to create the velocity that we require. Again, so far as kinetic energies is concerned, they all follow standard mathematical formulations, and as we add energy, it follows the linear momentum, and the scalar energies and fields follow the Lorentz contractions for velocity changes. But these contractions and changes only apply to the chem fields. And again, even spaceships travelling superluminally will have magnetic moments, and they will interact with other ships and planets travelling at similar velocities or differing velocities through these fields that they create. If you like, you can re-term chem fields in quantum mechanics into warp fields for faster than light travel. Again, it's not the mathematics or the physics that changes for one to the other. It's simply a scale of energy and a thorough understanding of the geometry of the energy that's creating the physics. As we mentioned, the Lorentz factor applies to all of the equilateral geometries in a mass energy field or a charge field or a chem field. This geometry could be the mass energy in a single charged fascia in matter, or it could be the chem field. It could also be half of a photon. It makes no difference. What we're measuring here is the energy content or the energy quanta per unit of time. And they all follow equilateral geometries. In the case of a chem field, the charged geometry will create a force through its linear momentum, or the square root of its field, when it superpositions with another field at any angle. But the angle of interaction will determine whether it's a Coulombic force or a Lorentz force or a mixture of the two. Again, mass energy is conservative, as is charge. So if this particle were to interact and annihilate, for example, with another particle, you would have to account for all the mass energy and all the charge geometries within the equations prior to the collision and after the collision, and how these mass energy geometries rearrange to create similar or different particles will determine the outcome of the collision. The only thing that isn't conservative in this type of collision is matter. Matter is simply a standing wave geometry of charge mass energies, So there is no requirement for the matter in to equal the matter out in any collision experiment. Only the mass energies need to be conserved. So this allows us to convert matter into energy. And that's what we'll do in Tetrionics to give clean, limitless energy to the entire world. Free energy, where we simply convert matter geometries into their neutral radiant energies, and we use these energies to create fields of electricity, etc., forced to do work. Again, all following equilateral geometries. And interestingly enough, as a side note, we can use any form of matter. The more radioactive or heavy the matter, obviously the more mass energy it has to release. And the ideal choice for this would be things like plutonium, radioactive iodine, other contaminants in our environment, nuclear weapons themselves, where we can take the radioactive material and convert its mass matter into mass energies, and use that mass energies for peaceful uses and supply it free to the entire world. And at the same time, we can clean up a lot of our radioactive toxic waste dumps and switch away from fission energy supplies to a matter to energy conversion process. Again, the geometry tells us that there is no limit to the velocity that we can create by adding energy momenta per unit of time. I.e., we can accelerate things to any velocity we care to choose, providing we have sufficient energy momenta quanta to reach that velocity. Again, we can quickly determine this from the geometry of Tetrionics for the field. Then all we have to do is use Newton's formula F equals ma for any given mass that we wish to accelerate, be it a neutrino or a spaceship. That's of course our inertial mass, so we calculate the energy for that given mass to reach a particular velocity. We simply use matter to energy conversion to release that amount of quanta per second to give us the velocity we require. Coincidentally, another side note, the energy that will be produced would be in the form of photons of energy. They would radiate bilaterally, so to reach the maximum potential you'd have to reflect some back, like you do with a torch with a reflector, so both beams of light go in the same direction. And one side effect of doing that would be that by releasing that much energy at once to create the motion, you'd also be creating a brilliant flash of gamma rays. Anybody trying to look as to where that, or anybody detecting that burst of gamma rays, who then tried to look at where the gamma rays came from, would of course see nothing, because A, it's taken a certain amount of time for the gamma rays to reach the detector, be observed, and then for the telescopes to swing to where it was. But B, in the meantime, your spaceship or whatever has accelerated at many times the speed of light away from that point. So when the telescopes are swung around to where the gamma ray burst came from, there would be nothing there to observe, because the ship would have moved away. A highly plausible and solid explanation for gamma ray bursters in our universe. And it also does away with the explanation that they are neutron stars or black holes that are producing them, because none have been observed where the gamma ray bursters come from, despite many decades of trying to do so. Additionally, Tetrionics will show in general relativity that black holes don't exist. So in the case of a magnet and its force, its fields of force, we can in fact show that the electric permittivity and the magnetic permeability of the fields store energy in the three-dimensional field around the bar magnet. The fields can do this because at the center of the bar magnet there always exists a singularity where the electric and the magnetic fields do not exist. It's normally called the block wall in magnetic experimentations or magnetic fields. It's simply where the electric and the magnetic fields come together and cancel each other out at, obviously, the point of maximum magnetic fields. You can say it cancels the electric fields out, but at the maximum point of maximum magnetic fields, it's where the north becomes the south and the south becomes the north. Again, purely the result of the geometry of the constants of the EM fields of a permanent magnet. It's these same fields that give us the Coulombic and Lorentz forces, as I've discussed. You can experience the forces by trying to overlap the fields as you push one bar magnet towards the other. The Lorentz force will come into play and push from one to the other. You try to move in from the side, you can see that while there is a Coulombic force here, it is completely overwhelmed by the magnetic field forces around the magnet close to it. As you start to experience the magnetic force, you're already weakening so far as Coulombic attraction, but you're in fact intensifying as far as magnetic attraction goes. Of course, you can cut the magnet in half, you'll cut the field, it will just simply rearrange the field into a similar field or same geometry field of a lower strength. The magnets will share this total field strength between them. Of course, you can measure them as bosons or photons, makes no difference. One's Lorentz force, the other one's Coulomb force. What makes a difference is when you put a conductive loop around it and move across the magnetic field, the force will change because the electric and the magnetic permeability constants will change as a result of the geometries. It's not a physical quantum foam or anything like that that's changing. It is a flat Euclidean geometric relationship that changes between the electric and the magnetic fields in all cases. And of course, you move across this EM field in any direction with a ruler. I encourage you to do so. As you move the ruler down or across this bar magnet, makes no difference. You will see that you are creating a changing magnetic and electric field, and that as the magnetic field increases, the electric will decrease, and as the electric increases, the magnetic will decrease in proportion to each other. This is not brought about by a change in the coordinate system or the velocity of the observer as described in relativity theory. It is brought about by the actual geometry of the energy momenta. And again, if you use bar magnets to determine the Lorentz force, you'll obtain a constant dependent on the strength of the bar magnets and their magnetic fields. You use those same bar magnets with a conductive loop to measure the EMF that it produces as you move the magnet through the loop of conductive wire. You can measure the Coulombic force or the current that it produces via the Coulombic force on the electrons in the loop of wire. It's not a case of a magnetic force becoming an electric force due to the change in the or the relative measurement of one field against the other. It's simply geometry. And again, the stronger the magnet, in the case of magnetic fields, the more quanta within the alpha geometries of the electromagnetic fields. Of course, to make a magnetic field, you need a positive and a negative charged alpha geometry. The stronger the magnet, the more energy you're putting into it when you're creating the magnet. Again, if you heat the magnet, what will happen is you'll add energy to it, but the energy will also be radiated in the terms of black body radiation as well as the EM field, and that'll weaken it. There there is a detailed discussion on the Tetrionic geometry, as it's shown here on the left, versus the relativistic explanation for a moving magnet or moving conductor experiment in terms of relativity's explanation as a changing frame of reference. This is not the case. What is the case is a changing geometry of the EM fields. Obviously, as we pack more energy into these fields, we increase the voltage that's available. Remembering again that there is a slight separation at the center here, where we have a purely magnetic, so we have separated the electric fields. So they are, for all intents and purposes, a separated voltage, but you won't measure them as such because, again, they have two sides that cancel out. But it does not; those two sides do not cancel out the dipole arrangement of the magnetostatic field. So it's weaker by far than the fully separating two charges, but we still have separated charges in terms of the E fields, and this separation allows us to create a EMF in conductive loops that move over them, and this is the basis of the electromagnetic force described by relativity, discovered by Faraday, and put to use by Tesla in all his equipment to give us electricity. The moving magnet with a stationary conductor will create a current, and a moving conductor around a stationary magnet will create a current, not because of any changing frame of reference as described, or any in relativity, or any distortion of fields of charged particles to create the magnetic fields in the conductors. This was an attempt to explain several features of electromagnetic fields and electricity that has lasted for a century now and needs to be replaced. All the mathematics is describing in relativity in terms of Ampere's law, Lorentz's force, all the physical constants, and how we generate electricity from electromagnetic fields, is simply a mathematical attempt to describe the equilateral geometry of alpha charges or charged geometries in the various combinations. Again, Tetrionics even goes as far as to show that this arrangement of EM fields in magnetostatic fields is exactly what's described by Euler's formula, although the mathematics never realized that that's what it was describing. As Einstein said, sometimes the more absurd an idea seems at first, the more hope there is for it. And Tetrionics certainly falls into that description. It seemed to me, even myself, a bit absurd to say square numbers are equilateral geometries, that the energy-momenta is simply the square root of that geometry, as well as its equilateral geometry itself, that quantized angular momentum is equilateral geometries. It equally seemed absurd that application of this geometry in energy momenta would explain all of the math of relativity, both general and special, as well as all the current formulations that have stood the test of time, particularly where we're changing the geometries from circular geometries to equilateral. But as you've seen here in this lecture and many others, and throughout the 5 ebooks that I've generated, application of the equilateral geometry at any stage to any formulation either reveals the formulation to be correct mathematically, or it shows where the mathematics has erred in the logical application of the math. And in doing so, we've completely underwritten relativity in the process. We've shown that the Lorentz corrections are not physical distortions of spherical bodies to create oblong magnetic moment. We've shown that the Lorentz contraction applies to the chem fields alone, that mass matter is invariant to velocity changes or acceleration, and that this equilateral geometry is the basis behind all the forces such as Coulomb and Lorentz forces within physics itself. We've shown that the relativistic motion, or the mass energies in the stress energy tensor of Einstein in relativity, can now be completely redesignated in terms and redrawn in terms of mass, energy and matter. And we use the mass energies of the chem fields to give us our units of force and our directions of force. And it's the geometry, the alpha, in all cases, from the quantum fields upwards, that gives us our constants. Whether it's the constant velocity of energy, or the speed of light in relation to frequency and wavelength, energy distributions within chem fields and photons, EM waves, or whether it's the permittivity and permeability that can be measured, whether it's the alpha constant of Planck's constant, or the equilateral geometry of energy. It all relates back down to alpha, the equilateral geometry. We can apply this, as we did in the previous lectures, to show that the equilateral energy-momenta quanta of chem fields of force can be redrawn as ideal inductive loops or vector rotations in one direction or the other for positive and negative, and that whether you look at them in terms of their equilateral geometries with linear momentum for the scalar fields, or whether you describe them as idler wheels of quantized angular momentum for positive or negative charges, you can in fact describe not only the fields of force, but you can also determine the constants of permittivity and permeability through the energy-momenta quanta within those fields. A classic example of where we've rearranged the formulation of a mathematical formula in terms of energy momentum is the mass energy momenta formula itself. Tetrionics shows this clearly in the case of chem fields to be a 1 pi charge geometry, alpha per c squared, giving us a linear force. And where that 1 alpha field is superpositioned, half of that field, or half mv squared, the electric component superpositions to give us a field of force and a constant for the Coulombic interaction. The constant obviously relates back to the square root of the Planck quanta for the field. For a given charge, you'll have a given linear momentum or square root for the scalar field. And it's this superpositioning of the linear momenta that gives you the force. Again, looking closely at the geometry, well, looking firstly at how it's formulated in QED, it's expressed as mc squared squared equals energy squared minus the momenta squared, or momenta energy squared. Showing this in the Tetrionic geometry for these same fields that give these forces, given with the Feynman drawings, we show firstly that there is no exchange of virtual photons or particles between the objects. They simply approach each other and experience a Lorentz force in this case. The magnetic fields superposition, and the energy between the energy in the magnetic fields that are superpositioned create a force between them. If it's a north-north pole arrangement due to the direction of particle travel, in this case here, using this one here for two particles approaching each other from opposite directions to mirror this, we can see that they're both electrons, So they would in fact have a south-north, south-north dipole arrangement of their magnetic moments, and they would interact firstly by the Lorentz force at a distance, but as they got closer they would have interact by a Coulombic attraction at a distance, but as they got closer there would also be a Lorentz force between the particles, because they more than likely wouldn't hit directly head on. They would graze past each other, in which case the Lorentz force would be a north-north arrangement, so they would repel from each other, bend away slightly, as drawn in the Feynman diagram. Again, Feynman QED versus Tetrionic illustrations. But whether it's a Coulombic interaction or a Lorentz interaction, it can still be described using the same superpositioned kinetic energies, in which case we see that the kinetic energy of each field that's superpositioned to give us the square can either be described as mass velocity squared, or momenta velocity squared. But you don't subtract either one. They are equivalent. You can measure the linear momenta by its velocity to give the scalar field, or you can measure the mass content by its velocity squared to give the scalar energy. It makes no difference whether you're referring to that or half of that for the kinetic energies. The geometric relationship is the same. So the forces and the constants that are produced are the same. And accordingly, where you see the mass energy momenta relationship expressed as E squared minus P squared C squared, you know that it is now incorrect. They are in fact equivalent formulations. Again, this shows from the geometry of mass energy momenta that the mathematics has been incorrectly applied or formulated. And that's a big incorrect one. That stems obviously, or harks back obviously, to using right angled triangles to explain energy momenta, mass, matter, and potential energies. Obviously the key to understanding force and where the constants of nature come from is understanding that Planck's constant is in fact a measure of energy or equilateral energy geometry. It's the alpha that's been hidden in our mathematical formulations that gives us our constants. It also gives us the strength of the forces, as well as the geometry of mass and matter itself. It's the key to all of physics, and it completely the understanding that the alpha is the equilateral geometry of quantized angular momentum is the key breakthrough that gave Tetrionics the leap forward in explaining and replacing all the errors in QM, QED, chemistry and cosmology, as well as redefining a number of mathematical premises as well. We show that superpositioning of the alphas in any form, be it electrical magnetic, will give us the coupling constant, referred to as the alpha coupling constant, mulled over for centuries now by physicists, described in many number of ways, but at all times, mathematically, they've been chasing the wrong number. It is not the inverse of 137, it is the inverse of 132. And this inverse of 132 relates directly to charge, to the speed of light, which again is only the square root of a 2 pi alpha field, to the relationship between energy, mass, which is of course c squared, E equals mc squared, and of course it's the constant in Planck's constant itself. The geometry is the constant. The mass is affected by the energy content. In this case, because we're referring to Planck quanta, or a quantum of Planck, it would be, the mass energy would be a constant as well, but it's constant through its geometry. The superpositioning of all these fields gives us fields of force, which of course propagate their energy through photons at their velocity, and the velocity is determined by their frequency wavelength relationships that result from the equilateral energy momenta within any superpositioned energy field, and that includes gravity. The force of gravitation is created through the energy density changes that matter creates within vacuum energy. Vacuum energy, of course, has an equilateral geometry of Planck quanta. It is just an extremely low density compared to that of matter. And conversely, it's higher than the energy density within matter itself. And that differential gradient between vacuum energy and null space energy within matter is what creates gravitation. And again, the gravitational constant will be the result of the geometry of the energy, as we indicate here. We show the Coulomb law and compare it to Newton's law for gravitation, although I more correctly term this Newton's law of gravity. Gravitation is the result of gravity plus electromagnetic field interactions. In either case, makes no difference. They're inverse squared laws as seen in the mathematical formulations. What changes obviously is what we're measuring, and that changes obviously the constant. You can of course think of Newton's gravity constant as a weakened form of Coulomb's constant, and in fact you can use Tetrionics to model it exactly that way, where you have the interactive electric field versus the convergent gravitational field. The geometries they create are inverse squared geometries, diamond shapes. What will change, obviously, even looking at these pictures, is that the Coulomb's constant has way more energy momenta of bidirectional action than Newton's gravity constant has, which is just a strictly convergent force of much weaker strength. Again, all we're doing is we're saying that this is the strength of the chem field, or the electrostatic field of the particle where it interacts, of the charged particle, and comparing it to the energy content of a gravitational field that's created by any matter. These are obviously identical matter, as these are identical charges, even though they're different charged, different net charges. They have the same strength fields, and these have the same amount of matter. Where we distinguish different matters, we will occasionally use a green small m for a different, just to distinguish that there is a difference. In this case, we would say that they are equal strengths, being identical capital M's for matter. But if we drew it as a small m, we can do so as long as we keep the colour green to indicate that it's a mass matter geometry, just not a mass. We could use I won't discuss where we use the green and blue together. That'll be in general relativity. But in doing this, we again show that the constants of Coulomb and Newton are again no more than superpositioned EM energy momenta, equilateral in geometry. And again, as we've drawn down here, whether the matter is charged or neutral makes no difference. Whether it's black body or chem field or electrostatic fields makes no difference. They're all born from equilateral Planck quanta. So they are exactly the same whether you're describing Coulomb's K, Newton's G, or the alpha constant, coupling constant itself. They're just different forms of measurement of the same thing. Tetryonics unites all of these different measurements through the geometry, alpha being the equilateral geometry, K and G just being reflective of the, firstly, the number of energy momenta, so the strength of the field, and then obviously the direction of the force of interaction. So we can in fact use Tetrionic geometry again to describe various things: kinetic energies, magnetic permeability, electric permittivity constants, the constants of gravity, of Coulomb's force charges, even acceleration itself in gravitational fields as well as interactive forces within electric fields. They can all be described. And when you look at the linear coupling versus the scalar coupling, you see that they in fact cancel out. So thus explaining why alpha has been hidden in Planck's constant for so long. Again, alpha has been hidden through our determination of charge. Charge in QED has never been explained. It's normally described as the force that one particle can exert on another when that other particle enters its field of charge. It does nothing to explain where charge comes from, what creates it, what gives it the strength, what gives it its interactive properties. Again, Tetrionic geometry from the equilateral triangle and the square root linear momentum gives us all those properties. And more importantly, alpha itself is the primary constant. It's the equilateral geometry of energy. And alpha per c squared, which is the first measurement of geometry, energy geometry in a spatial coordinate system, will give us a unit of time. It's the time component in space-time. Charge, which is mass time, mass seconds, is a measure of charge. It's a two-dimensional energy time, if you like, time per second. You're measuring the energy geometry and its charge within a region of within a spherical spherical coordinate system, c squared. So where you measure the geometry, the alpha, you determine the charge, which if you just do the basic algebra, square meters per second for quantized angular momentum by second squared per meter squared for the inverse of c squared, you get per second. You get seconds, sorry. This gives us time. So quantized angular momentum per c squared, or per spherical coordinate system, per region of space, is in fact time. So as we measure our measurements of time, our perception of time is based on changes in our environment, whether it's the sensing of a breeze blowing, the grain of sand dropping down, water flowing, whether it's mass, energy, or changes in momentum, makes no difference. They are all measurements of changes of time, of energy, within a region of a coordinate system. So we can say by definition that time is simply a measurement of changes of energy in any of its form, mass, energy, or matter. Where we measure it in terms of mass, angular momentum, or Planck's constant, we're obviously measuring the charge, mass seconds mass being amperes, and so forth, current being the number of charged masses past a region per unit of time. They're all related, and they're all explained in Tetrionics. But here what we've got is a relationship where charge is time, something that's not expressed properly in the mathematics, or where it's expressed, it's just given as a function, which people then extrapolate to say, I'd like to do a study on time travel, or is time travel in Doctor Who possible? Clearly what we can show here, so far as the two directions of time in all formulations of mathematics for physics, is that the formulation of positive and negative time simply is an expression of positive and negative charge, or the directions of energy flux within any region of time to create the electrical equivalent of a charge, i.e. a quantum inductive circuit, in which case a negative rotation of energy will give us a negative charge. A positive rotation of energy will give us a positive charge. So to be very clear, where we're talking tetrionic charges, we're talking the geometry per spatial coordinate system. Where we're talking current or amperes, whatever, we're talking mass, any form of charge itself, we're talking mass seconds. And where you see time in relativity formulations, you can now exchange the word time for charge. So relativity for a number of years now has expressed charge as being a key component of mass, energy, matter and its physics. Tetrionics, through its geometry, shows us how that comes out. Of course, we've got a finely tuned universe, and we'd be remiss if we didn't discuss, or rehash obviously, where the fine tuning comes from. It of course comes from the geometry. Whether it's mass or energy measurements, whether it's measurements of time or positive or negative charge, whether it's measuring the forces between charged particles or just neutral matter, makes no difference. On any scale, all the relationships of permittivity, permeability, Planck's quantized angular momentum, time itself, Rydberg's constant, linear momentum, pi radians, the equilateral geometry, all these constants come from the equilateral geometry of Tetrionics, or of specifically equilateral geometry of energy. And it's changes to the energy content per spatial coordinate system that gives us the foundation of our physics and all our measured forces. Again, looking closely at the quantized angular momentum, or the equilateral geometry, we can see that not only is it responsible for charge, it also is the basis for the conservation laws expressed by Emily Noether. She expressed them mathematically. Tetryonics draws them geometrically. Whether it's charge, angular momentum, energy momenta, mass, charge parity time, or charge momentum time, the electric and magnetic constants or their forces, the velocity of light that any energy can produce, its wavelength, frequency, relationship to its velocity of propagation, all of them are expressed through their conservation laws. And basically, as everyone knows, that just simply says that whatever goes in must come out in the same forms. The only exception to this in the conservations is we obviously have conservation of angular momentum or charge, we have conservation of energy and mass, and we have conservation of momentum. If in the case of linear, it's linear momentum, square roots. In the case of angular momentum, it's the charge that's being conserved. So what Emily Noether was expressing was that mathematically it's shown that the conservation laws are the result of a symmetry. Tetrionics shows that symmetry is the equilateral geometry of alpha. And it's the coupling of alpha geometries that gives us our fields and strengths of force. The only thing that isn't conserved in physics is matter. Matter is the way out to allow us to get increased energies, to travel at the speed of light or faster. Matter is how we will clean up our environment of toxic biological and radiological wastes and create a whole new technology and civilization based on the equilateral geometry of energy. That concludes our discussion here on symmetry and conservation laws and force laws and how they all relate back to equilateral energy geometries within Tetrionics.